What are the sides of a dodecahedron prism? At first, this question may seem complex or even meaningless, but I assure you, finding the sides, cells, or facets of a prism in any dimension is extremely simple. Let's start somewhere simpler. What is a prism? In geometry, when you extrude a polytope into the next dimension, for example this pentagon, you get what's called a prism. The key bit here is that when you extrude or prism a shape, every part of the shape gets extruded. The pentagon's vertices get extruded into edges, and the edges get extruded into rectangles. And the pentagon, of course, gets extruded into a pentagon prism. Using this fact, we can reasonably deduce that the pentagon prism has 5 rectangular faces and 2 pentagonal faces. Now for the dodecahedron prism. We can extrapolate this logic to any higher dimension. The dodecahedron is a 3D 12-sided shape with pentagonal sides. Since we're only being asked about the sides of the shape, which means the highest dimensional components of it, in this case 3-dimensional cells, it's really easy to figure out. We can think of extrusion another way, taking 2 copies of the base and offsetting them in the new dimension, and then connecting them. If we do this, we get 2 dodecahedral cells. Then we connect their pentagonal faces using pentagonal prisms. Another harder example. Wow, that was surprisingly simple. Now, with only the information of the sides the base has and how many sides it has, you can tell people the size of its n+1 dimensional prism. Let's look at one more example. This is the 600 cell. It's a 4-dimensional regular polychoron with 600 tetrahedral sides. It may sound intimidating, because it is, but if we extrude it into 5D, it becomes simple to answer what the sides are. The 4D facets of a 600 cell prism are 600 tetrahedron prisms and 2 600 cells. Try it yourself! Alright, let's test your knowledge. What are the sides of a hexagon prism? What are the cells of an icosahedron prism? What are the 4D facets of a 24-cell prism? Thanks for watching, and have fun exploring higher dimensional space.